Let me first write the general form of a quadratic equation on top. It's ax squared plus bx plus c equals 0. It's a quadratic equation in variable x. Note that the degree of the polynomial on the left is 2. And do you remember the conditions? A is not equal to 0 and a, b and c are real numbers. Now I will give you an equation on the screen and you need to tell me if it's quadratic or not. Here you go. Is this equation quadratic or not? The degree of the polynomial on the left is 2 and the constant a is 1, which is not equal to 0. So this is a quadratic equation. A is 1, b is -7 and c is 12. This is a quadratic equation in variable x. So I will keep the standard form on the screen for you and erase the rest. Here's the second equation. I know this one is not straightforward, but I'm sure you'll be able to tell if it's quadratic or not. Give it a shot. Do not assume that because there is no x, it cannot be a quadratic equation. It can be a quadratic equation in variable d. It doesn't always have to be variable x. So here, all we need to do is solve it a bit further and get all terms on the left side of the equation. D plus 1 the whole squared can be written as d squared plus 2d plus 1. Transposing the terms on the right to the left, we get this equation. And this is the quadratic equation form. The answer is yes, it is a quadratic equation in variable d. Now let me give you the third equation and the fourth one on the screen. Are these quadratic equations or not? Did you try solving the third one further? This is what you should have got. This is the final equation we get. Is this a quadratic equation? Nope, it's not. And that's because the degree of the polynomial on the left is 1, not 2. One mistake that most students do when they see an example like the third one is that they see that the largest power of x is 2 on both sides and hence it must be a quadratic equation. But only after solving it properly, we realize that it is not a quadratic equation but a linear one. Okay, did you try the fourth one? Do you remember the formula of the identity a plus b the whole cubed? It's a cubed plus 3a squared b plus 3ab squared plus b cubed. Applying this identity here, we get this. X cubed will get cancelled from both sides and we will be left with this. Could you try solving this further to see what you get as the final equation? This is the equation you should have got. This big equation was solved to get this equation, which clearly is a quadratic one. And you can guess the silly mistakes that students make here. They see the power as 3 initially and assume that it's not quadratic. So now you know what quadratic equations are. What we will move on to now is how you solve them.